Okay, going to look at the difference between classical and empirical probability. First off, I think we're going to be able to do the classical probability right away. Classic probability for a coin, okay? Let's concentrate on heads. Going to concentrate on heads. So what is the probability of getting a heads when you flip one coin? 50%. So we've got some choices here. I'm not going to quiz you over this, but this helps us dive into equals 1 divide 2, or you could just put in 0.5. This is a pretty simple thing. It's the next one that I'm going to want a formula for. But in order to get this formula, we're going to have to do a simulation. This is a large numbers probability where I want to do a huge simulation. I want the computer to flip a coin 100 times. So we're going to have to write off to the side somewhat of a legend or a key. So I'm in E1. I'm just going to type that heads is 1 and then tails will be represented as 2. All right? Heads is 1, tails is 2. Then I'm going to go into cell A1. I want the computer to choose between 1 and 2, and 1 and 2 only. These are integers. So here's the formula. It's called rand int. I hit equals R-A-N-D. Oh, it's rand between. Sorry, rand int on a graphing calculator. Rand between. You could either have all lowercase or uppercase, it does not matter. But equals rand between, the smallest value is 1, comma, the biggest value is 2, close parentheses. I hit enter and it flips the coin. We get a head, or I got a heads. Anybody get tails? Yeah, because it's randomly choosing. Well, what's going to happen is I want to do this 100 times. Some of you have to learn how to do copy and paste. Here's what copy and paste does. You have to reselect that A1 cell. You have to make your cursor. So notice my cursor is an arrow. You have to reselect to where your cursor is a plus sign. You're going to go all the way down to 100 because I'm not going to manually put this in. I keep scrolling down to get 100 trials. Wait, not 100. Yeah. All right. It flips my coin 100 tries. So we want to know the probability of getting a heads. The probability of getting a heads. We are going to learn the formula count if. So I'm going to zoom in again, but I'm going to go on the empirical probability. We want the number of heads counted and divide that by 100 trials. So I'm going to hit equals. Count, whoops, not sound, un momentito, COUNTIF. We're going to count if, open parentheses, we're going to count if the cell contains a 1. So the first piece is what you want, comma. Oh, wait, hold on. I might be doing this wrong. Let me click the question mark. Oh, I need the range first. Range means what is the cells? What's the cells? And then they want your criterion. That's where we're going to put the 1. So I'm going to count if, let's select the range. I have 2 options for this. Either type it or I could click and drag all the cells. All right, I like to click and drag. I like to click on A1, and then I'll go all the way down to A100. Scrolly uppy. Or I could just type A1 colon A100, comma 1. Close parentheses. That's going to count all of my heads. Currently, I have 43 heads, but you're probably going to have a different number. Does anybody have 43 exact? Oh, dang, girl. Okay, we both have 43. Okay, so 43 exact. I'm going to now divide that by 100 to get a probability. yesterday or the day before, we talked about how probability has to be a value between 0 and 1. It can't be bigger than 1. I hit enter. We're not going to autofill this. No. Not going to autofill. But anyway, we're going to compare how the classical probability and the empirical probability are pretty close. All right, so the law of large numbers. Let's go down to 100 and copy and paste this for another 100, all the way up to 200, and see if we can get closer to 50%. But the thing is, after we increase that to 200, now I have to change my empirical formula, not just count to a 100, but now we need to count it to, here, let me zoom in. Hold on a second. Zoom in. We're going to change the range to 200, and we're no longer dividing by 100 cells. We're now dividing by 200 cells. So when I hit enter, I am no longer 55 hundredths. Now I'm a little less. But is anybody actually at 50%?
Was it 100?
Huh?
Was it 100? Like before, like when we only went to 100, it was. And now.
So let's go over to the next one. Well, we're going to fill in the classical probability first. We're going to do probability of getting a 1. So what's the probability of getting a 1?
16% repeating.
So I'm going to put equals 1 divided 6 because, like in Khan Academy, this is a repeating decimal, and I'm not going to round it off. I'm just going to hit equals because we're going to actually look to see, like, how close can we get to 1/6? All right, we're going to repeat the process. We're going to use an A1 cell equals rand between open parenthesis. The lowest value on a die is 1, and the highest is a 6. And I'm going to hit enter. My dice rolled a 1. Oh, how ironic.
I got it too.
Okay, so we're all over the place, but I'm going to repeat this to 100. So I'm going to reselect the cell and copy and paste it for 100 trials. There we go. And what I'm going to do is scroll back up to empirical probability and hit equals. I want to count, C-O-U-N-T, if, open parentheses, A1 colon A100, if that range got me the probability of 1. I close parentheses, but that's not all. I want that divided by the number of trials, which for this one is 100. I hit enter. I do not do the autofill. Let's do the next experiment where we go down to the 100. We copy and paste this for another 100. There we go. And then we scroll up to empirical probability. And okay, so now we're going to 200 for both the the range and the sample space to see what we get. That's not all. Let's go to the multiple choice test. We're going to do only 4 selections. So empirical probability to get the right answer is 1 out of 4. Let's put a thing off to the side. Oh, you know what? No. Wait, yes. Okay, we're going to let A be 1, B be 2, C be 3, D be 4. That'll be our answer key. We're going to do the formula again. Equals rand between The lowest value will be 1. The highest value will be 4. Close parentheses. So currently, I have, a 2 represents B. So my multiple choice right answer was B. I'm going to do this for 100 trials. After copy and pasting, we got most of our class saying C is what they choose. So let's see, C is number 3, so I'm going to choose 3. And then I'll divide by the 100 trials. Don't autofill. So I'm pretty close. This is a pretty close representation. And again, I can do another 100 trials to just see if I can get closer and closer to 0.25. Now that we've done some experimentation with large numbers probability, I'm going to have you go back to Google Classroom, click turn in because you've done the thing and you get credit for doing this while teaching. But now we need to go over homework questions. So those of you at home, do the homework. Bye.